Hello class, in this lecture I will be talking about hypothesis testing, uh, proportions problem with two-tail. So I will use this problem to solve and understand the concept of proportions for a two-tail problem. So a publisher reports that 54% of their readers own a laptop. A marketing executive wants to mm, test the claim that the percentage is actually different from the reported percentage. A random sample of 140 found that 50% of the readers owned a laptop. Is there sufficient evidence at the zero point 0.02 level to support the executive's claim? So here the publisher reports 54% of the readers own a laptop. So this is population proportions. So population proportion is given as 54%, which is 0.54, and then uh, random sample of 140. So our sample size is 140 and the sample proportion p hat is 50%, which is 0.50, and our alpha significant level is given as 0.02. So this is what is given. So to do hypothesis testing, I told you previously, the first step is to define hypothesis. So we have null hypothesis and then we have alternative. So here the marketing executive wants to test actually um, test the claim that the percentage is actually different from the reporting percentage. When we say different, it can be lower than this 0.54 or higher than 0.54. So this is a two-tail problem. So that means the proportion which the publisher reports is 0.54 is exactly equal to 0.54, and the alternative will be not equal to 0.54. So if it is less than 0.54, publisher's claim is wrong. If it is more than 0.54, the publisher's claim is wrong. So to support that claim, they took a sample, and this is what our sample data tells, where we took a sample of 140 and then we have a p hat of 0.50, which is sample proportion, and significance level is 0.02. So the next step of hypothesis testing is to compare test statistic with critical value. So as we know, the test statistics for proportion, we are using z. So we will be using z stat. So the formula would be the same as one tail, which we discussed previously: p hat minus p over square root of p 1 minus p over n. So we will substitute those values here. So our values are: p hat is 0.50, and then p is 0.54, and then square root of p is again 0.54, 1 minus 0.54 over n is 140. So this is going to give us negative 0.949, which is negative 0.95. So that is our test statistic value. So we will keep this. Now the critical value, for a two-tail problem, it would be z alpha over 2 So this is a two-tail problem. If it is one tail, it would be Z alpha, one tail. Since this is a two-tail problem, we will be using Z alpha over 2. That means both sides of a normal distribution curve. So they gave us an alpha value which is 0.02. So the other way of saying is this is 98% confidence interval. So now I will try to represent this in a normal distribution curve and see if we can understand. So I have a normal distribution curve, and this curve represents the publisher's claim, which is P is equal to 0.54. So P is equal to 0.54, and then they gave us alpha as 0.02. So since this is a two-tail problem, we do this, and the area, this plus this both together should be 0.02. So this will be alpha over 2, which is 0.01, half of it, and this will be alpha over 2, which is 0.01, half of it. And again we said 98% confidence interval, so this will be 0.98. So this is where the claim of the publisher is true. So that means in this region P is equal to 0.54 with 98% confidence will be true. So we will say do not reject H null in this area. And then if we have, that means this area, so this whole area and this whole area, we reject H null and then reject H null. So now I wanted this value and this value. What is Z alpha over 2? Z alpha over 2. So since our Z table gives us left side of the curve, we can go and look for Z alpha over 2, which is Z at 0.01 probability. So I will go to our canvas and then go to module 0 and do calculation aids and then statistical tables. So I will do enable editing, and currently I am in Poisson table. I have to go to Z table. So I go to Z table and look for probability of 0.01. So this is what I am looking for, 0.01. I'm sorry, so I will just do Z 0.01. So I'm looking for probability of 0.01. So I will go and look for 0.01. So that is somewhere here or here. So it is negative 2.32 or negative 2.33, whichever you want. So I will take negative 2.32. So this value is negative 2.32. So the Z value here, this one, is negative 2.32. So this will be positive 2.32 as it is a symmetrical curve. So now I will go and compare this with I will try to compare it with test statistics. So I'm looking at our test statistic, which is negative 0.95. So where does negative 0.95 lie? So here we have negative 2.32, negative 0.95 will be somewhere here, 0.95. So that falls under do not reject regions. So we are in do not reject. So our conclusion is do not reject. So that means, okay, so do not reject H null. That means this statement is true. So that means our publishers claim that 54% of their readers own a laptop is true. So I will go and type this, look at, try to answer this in Hawk's Learning. So that means publishers claim is true. Let me go to Hawk's Learning. So they are saying there is sufficient evidence to support the claim that the percentage of readers who own a laptop is different from 54. No, it's equivalent to 54. So that means there is not sufficient evidence to support the claim that the percentage of readers who own is different from 54. So there is not sufficient evidence. When we say the publisher's claim is true, which is 54%, there is, it's different is 54%, there is not sufficient evidence. So that's how you will answer this question. So I will go to our calculation aids and try to answer the try to solve this problem using our calculation aids. So again, this is calculation aids. I will copy our hypothesis and then our data. So this is the part I'm going to copy. So our hypothesis is H null is equal to 0.54 and then H alternative is not equal to P not equal to 0.54. So H null P is equal to 0.54, H alternative P not equal to 0.54, and our data is given data. Let me go and look at the data. So they gave us let me see, they gave us n is equal to 140. So the sample size n is 140, p hat is 0.50. So that is what is given. Okay, p hat is 0.50 and alpha is 0.02. Alpha is 0.02. So I will go to our Canvas page again. So Canvas, I will go to modules, module 0, and then calculation aids. Go to chapter 10, calculation aids. And then do enable editing. Now we are in proportion test worksheet. So since our problem is a two-tail problem, so we will be using So again you have to look at this p hat p not equal to, so that is what our alternative would be. So if you see, alternative is p not equal to, so that means I'm going to key in my values here. So the first value, let me see what they are asking. Population proportion is what we have to key in, so I will go here and mm, population proportion is 0.54. Let me see, 0.54. So I will key in that value. mm, so this would be mm, 0.54, and then p hat is given as 0.50, so this is 0.50. Alpha is let me check what is alpha. Alpha is 0.02, and then sample size is 140. So again our test statistics value is 0.95, 2.32 is our critical value, and don't reject. So that is how we will be solving this problem. So this concludes my lecture on proportions two-tail problem. Thank you.